Let's keep rolling here. Letter D. We have 8 sine 15 cosine 15. Now, I don't think it helps much to say, well, this is A, this is A. But it actually does. There's something similar to this, not exact. We're looking at something that said 2 sine of A, cosine of A. That would have been great had we been given a 2 instead of an 8, but it's really not that big of a deal. I mean, it's simply 4 times 2 sine of A, cosine of A, or 4 times 2 sine of 15, cosine of 15. So this right here is my double angle formula for sine. It's sine of 2 times A. And then we just say, okay, but I got to multiply that by 4 to get this particular mess up here. So what we're looking at is 4 times the sine of 2 times, well, A is 15. So it's basically 4 sine of 30 degrees. The sine of 30 is a half. So it's 4 multiplied by a half, which is simply 2. Answer. Okay, letter E. 2 cosine squared 157.5. Again, we'll call that A. 2 cosine squared A minus 1 is definitely one of your double angle formulas for cosine. So that would be a cosine of 2A. So what we're looking at here is cosine of twice of 157.5 degrees. What are we looking at? 157.5 would be 315, I believe. So cosine of 315 degrees. Try harder. Draw a 315 degree angle. Puts us in Q4. Now, cosine is positive in quadrant 4. I mean, we can rewrite this as a positive cosine of the reference, 45. We could handle it this way and just say our answer is square root of 2 over 2. I mean, assuming we know that the cosine of 45 is the square root of 2 over 2. Or you could just draw your triangle directly in quadrant 4 like we used to do. There's 1, there's negative 1, there's square root of 2. Cosine is adjacent over hypotenuse, so 1 over the square root of 2. Rationalize the square root of 2 over 2. Letter F. 2 tangent 7 pi eighths. I guess you're the A, and you are also the same thing, A. So it's 2 tan of A over 1 minus tan squared of A, which kind of resembles your tan double angle formula. Tangent 2A. So we're going to say this is tangent of twice of 7 pi eighths. 2 times 7 pi eighths, which is 7 pi fourths. 7 pi fourths, again, little mental math. Pi fourths is 45 degrees. We want 7 45 degree angles. I think that's 315 degrees. Tangent 315. We could redraw the picture. Just look back there at the green, but that was in green. We need to draw it in red. So 315. Reference 45. Let's just use the triangle in quadrant 4. So 1, negative 1, square root of 2. Tangent is opposite over adjacent. So we're looking at negative 1, opposite over adjacent. All right, letter G. We have negative square root 1 minus cosine pi. Again, I guess if we call that A, this should be very recognizable as, it said plus or minus out in front, but this is your sine half angle formula. So what we're going to say is negative sine half angle formula. So negative sine of, what are we taking half of? Well, we're taking half of pi. Pi halves is 90 degrees, or we could just think what the sine of pi halves is. It is quadrantal. When you graph a sine, remember how that works. I'll use 2 slashes here because we're interested in what happens at pi. Well, Sine starts right here on the y-axis, climbs, then falls, then who cares? Because the sine of pi is 0. So we're looking at sine of pi halves. That wasn't good. We're looking for the sine of pi halves, not the sine of pi. The sine of pi halves is 1. So I don't know what the difference between those two are, but final answer should be negative 1. Let me give you an alternative approach to this, only because of the cosine of pi. If you were to just simplify this without a half-angle identity, remember what cosine looked like? So here's pi halves. Let me not make the same mistake again. That's 3 pi halves. That's 2 pi. Cosine of pi is, if you see this, cosine of pi will be negative 1. So you can actually directly substitute in negative 1 there, and I think handle this even easier than what we did originally. So 1 minus a negative 1 over 2. Well, 1 minus negative 1 is 2. So you have negative square root of 2 over 2. You have negative square root of 1. That is not a 1. That is a 1, which is negative 1. Same answer, just a little bit different approach. I would not recommend that approach on the others. Those, you definitely need those double in half, but sometimes you can get away with little shortcut simplifying.